At the edge of Antarctica, most fragile ice giants is splintering so violently that it is sending out its own earthquakes. The so-called Doomsday Glacier is not only cracking apart, it is now producing a drumbeat of iceberg quakes that reveal how close this system may be to a tipping point. Those hidden tremors, recorded far from human ears, are a warning signal that the glacier's seaward front is destabilizing in real time. As I trace what scientists are learning from these quakes, the picture that emerges is of an ice sheet under growing stress, with consequences that reach far beyond the frozen edge of the continent. The glacier that has earned the nickname Doomsday Glacier is not just another block of ice on a remote map. It is a linchpin of the West Antarctic ice system, and if it were to collapse entirely, scientists warn that global sea level could rise by around 3 meters, enough to inundate low-lying coasts and displace millions of people in every ocean basin. That scale of change would redraw shorelines, swamp infrastructure from New York's subway tunnels to the ports of Mumbai, and force coastal communities to decide which neighborhoods to defend and which to abandon. When I look at the projections, what stands out is how tightly this single glacier is tied to the fate of cities that may feel very far from Antarctica. Analyses of the Doomsday Glacier's potential to raise sea level show that a full collapse would not be a slow, but a direct driver for forced migration and economic loss within the lifetimes of people alive today. That is why researchers treat this glacier as a global risk, not just a polar curiosity. The most immediate sign that the Doomsday Glacier is in trouble is the way its surface and edges are fracturing. One part of this glacier floats atop the ocean and stays partly pinned by a crucial spot along its northern edge, a kind of natural anchor that helps hold the ice in place. As warming water and air attack that floating tongue, cracks are radiating through it, weakening the structure that keeps the inland ice from sliding more quickly toward the sea. From my perspective, that pinning point is the glacier's Achilles heel. Once it fails, the flow of ice behind it can accelerate, much like a traffic jam suddenly clearing when a bottleneck disappears. Researchers tracking the region describe how cracks in one floating section are already linked to faster than expected collapse, a sign that the glacier's structural supports are eroding faster than many models anticipated. As the ice front weakens, it is not just visible fractures that tell the story, but a new kind of seismic noise. Scientists have now detected hundreds of iceberg earthquakes at the crumbling end of Antarctica's Doomsday Glacier. Tiny tremors generated when massive blocks of ice crack, bend, or break away. These events are distinct from tectonic quakes, but they register on sensitive instruments hundreds of kilometers from the origin, turning the glacier into a source of its own seismic soundtrack. What strikes me is how this discovery effectively gives us a stethoscope on the glacier's most unstable zone. By cataloging hundreds of iceberg earthquakes at the glacier's front, researchers can track when and where the ice is failing, even during the long polar night when satellites see little and fieldwork is impossible. Each quake is a data point that helps map the pace of disintegration and the stresses building within the ice. These iceberg quakes are part of a broader class of glacial earthquakes that behave differently from the jolts produced by shifting tectonic plates. And glacial earthquakes tend to the movement and breaking of ice rather than rock. At Antarctica's Doomsday Glacier, hundreds of earthquakes have now been detected, and their timing and strength vary with the seasons, hinting at how environmental conditions modulate the glacier's internal stress. For me, the seasonal rhythm of these events is one of the most telling clues that climate is in the driver's seat. As polar regions warm faster than the global average, the pattern of hundreds of earthquakes detected at this glacier becomes another line of evidence that rising temperatures are reshaping the mechanics of the ice. The quakes are not just curiosities. They are a real-time measure of how a warming world is destabilizing one of its largest frozen reservoirs.